This 1960s bulldozer could push 30% more material than modern equivalents twice its price. This forgotten beast had a blade force that today's machines still can't match. And this Cold War-era dozer, it's been banned from production because it was too powerful for modern safety standards. The golden age of bulldozers produced monsters that make today's models look weak. Let's uncover 10 forgotten legends. Number 10. Allis-Chalmers HD41. Starting at number 10, we have the Allis-Chalmers HD41, a behemoth from 1960 that most people have never heard of, yet it fundamentally changed what bulldozers could do. The HD41 weighed in at 95,000 pounds and was powered by a naturally aspirated diesel engine producing 524 horsepower. Now, modern dozers in this weight class produce similar horsepower numbers, so what made the HD41 special? Torque. Ungodly amounts of torque. Allis-Chalmers designed this machine with a gear reduction system that was, frankly, absurd. The final drive ratio was so aggressive that the HD41 could generate over 180,000 pounds of drawbar pull. That's the actual force transmitted to the ground. For comparison, a modern Caterpillar D10, which weighs significantly more, generates around 160,000 pounds of drawbar pull. The HD41 achieved this through pure mechanical advantage. Instead of relying on electronic controls, variable transmissions, or computer optimization, Allis-Chalmers just used bigger gears, heavier shafts, and more robust clutch packs. The transmission alone weighed over 4,000 pounds, about what an entire compact car weighs. This brute force approach meant the HD41 could push through material that would bog down modern machines. Operators who ran these dozers in the 1960s and 70s report that it would just keep pushing, no matter what was in front of it. Trees, stumps, boulders. The HD41 didn't care. It had one speed, forward, and it did that with relentless force. The downside? It consumed fuel like a small refinery and required constant maintenance. Modern dozers are 3 times more fuel efficient and can run circles around the HD41 in terms of finesse work. But for raw pushing power in a straight line, the HD41 was a monster that modern engineering has never quite replicated because they've never needed to. Today's machines are smarter, but the HD41 was stronger. Number 9. International Harvester TD40. At number 9 is the International Harvester TD40, a crawler tractor that represented the absolute peak of IH's dozer engineering before the company collapsed. Introduced in 1959, the TD40 was International Harvester's answer to the question nobody asked: what if we made a bulldozer that could survive a nuclear war? The result was a 105,000-pound machine that was overbuilt to a comical degree. The frame was constructed from steel that was 40% thicker than competitors used. The track pins were designed to handle 3 times the expected load. The engine block was cast so heavily that it alone weighed over 3,000 pounds, more than the entire engine assembly in many modern dozers. This wasn't elegant engineering, it was paranoid engineering. But here's where it gets interesting. That paranoid overbuilding resulted in a machine with phenomenal ground pressure distribution and incredible stability. The TD40 could work on slopes that would tip modern dozers. It could push through loose, wet soil that would bog down contemporary machines because its tracks distributed weight so efficiently that it essentially floated on terrain others would sink into. The power-to-weight ratio wasn't impressive by modern standards, 450 horsepower pushing 52 tons. But the TD40 had something modern dozers don't, a direct drive power divider system that put nearly 90% of engine power directly to the tracks with minimal loss. Modern dozers, with all their sophisticated transmissions and hydraulic systems, lose 20 to 30% of power to mechanical overhead. The TD40 was crude, but it was efficient in its brutality. Operators from the era report that the TD40 would chug through anything at a steady, inevitable pace. It wasn't fast. Top speed was about 6 miles per hour, but it never stopped. Stumps, rocks, frozen ground, it didn't matter. The TD40 just kept moving forward with mechanical certainty. Number 8. Caterpillar D9G. Number 8 brings us to a machine that many consider the pinnacle of mechanical bulldozer design. The Caterpillar D9G. Produced from 1974 to 1980, The D9G was the last of the purely mechanical D9s before Caterpillar started adding electronic controls and fuel-saving technologies. It represented the absolute peak of what could be achieved with steel, diesel, and mechanical engineering alone. The D9G weighed 106,000 pounds and produced 410 horsepower from its naturally aspirated D353 engine. On paper, it's significantly less powerful than a modern D9T, which produces 474 horsepower and weighs about the same. So why is the D9G on this list? Because it was stronger where it counted. The D9G's blade could generate 85,000 pounds of maximum cutting force, the actual force applied to material during a cut. Modern D9Ts generate around 72,000 pounds. How did Caterpillar achieve more cutting force with less horsepower? Through mechanical advantage and weight distribution. The D9G's blade mounting system used a simple but massive hydraulic cylinder arrangement that created exceptional leverage. The blade was also significantly heavier, solid steel construction, without the weight-saving measures modern engineering employs. This created more downforce, more momentum, and more cutting ability. Additionally, the D9G's center of gravity was lower than modern equivalents. Caterpillar achieved this by mounting the engine and transmission closer to the frame. This made the machine less stable on extreme side slopes, a trade-off modern engineers won't accept, but it gave the D9G unmatched pushing stability on level ground and forward slopes. Operators who've run both D9Gs and modern D9s report a distinct difference. The D9G feels more planted, more immovable. When pushing heavy loads, modern D9s will occasionally break traction or lift the blade involuntarily due to computerized load sensing. The D9G just pushed. No computer would interfere. If you wanted to push until the track spun or the engine stalled, the D9G would let you try. This made it dangerous in inexperienced hands, but incredibly effective with skilled operators. The D9G became legendary in heavy earth-moving, mining, and land clearing. Many operators considered it the strongest D9 ever built. Caterpillar stopped making the D9G because it failed emission standards and was too fuel-hungry for the 1980s energy crisis. Thousands remain in operation worldwide, often preferred by contractors who prioritize power over efficiency. Parts are still available, and many D9Gs have been rebuilt multiple times because their mechanical simplicity makes them essentially immortal. Number 7. Fiat Allis FD50. At number 7, we venture into truly obscure territory with the Fiat Allis FD50, a machine most Americans have never heard of, but that European contractors still speak of with reverence. Produced from 1977 to 1982, when Fiat and Allis-Chalmers had a brief partnership, the FD50 was an attempt to create the ultimate European bulldozer. The result was a 130,000-pound monster that combined Italian durability obsession with American power philosophy. The FD50 was powered by a Fiat turbocharged diesel producing 580 horsepower, enormous for the era. But power wasn't what made it special. What made the FD50 legendary was its undercarriage design. Fiat engineers, coming from a tank-building background, designed the FD50's track system using principles from military vehicles. The tracks were wider than anything else in its class, distributing ground pressure to just 12 psi, less than a human footprint. The track pins were hardened to military specifications. The rollers were sealed units designed to run for 10,000 hours without maintenance. This undercarriage made the FD50 unstoppable in conditions where other Dozers failed. It could work on swampy ground, snow, loose sand, anywhere ground pressure was an issue. European contractors used FD50s for land reclamation projects in the Netherlands, where standard Dozers would sink. The blade design was equally impressive. Fiat used a semi-U configuration that was significantly taller and wider than American equivalents. This allowed the FD50 to move enormous volumes of light material like snow or wood chips up to 45 cubic yards per pass, compared to 25 to 30 cubic yards for competitors. But the FD50 had a fatal flaw. It was too expensive. The military-grade components and overbuilt design made it cost nearly 50% more than a Caterpillar D9. In the recession of the early 1980s, contractors couldn't justify the premium, even though the FD50 was objectively stronger and more capable. Fiat Allis built fewer than 1,500 FD50s before discontinuing the model. The partnership dissolved shortly after, and the design was abandoned. Today, FD50s are extremely rare. A few operate in Scandinavia and Eastern Europe, where their ground pressure advantages are still relevant. Parts are nearly impossible to find, so survivors are maintained through fabrication and adaptation. The FD50 proved that sometimes being the best isn't enough. In a market driven by price and brand loyalty, a superior machine from an unfamiliar manufacturer couldn't compete. But for those who ran them, the FD50 was the strongest dozer of its era, pound for pound. Number 6. Euclid 8280. Coming in at number 6 is the Euclid 8280, a machine so powerful that modern safety regulations would never allow its production today. Euclid, before being absorbed by various corporate mergers and essentially disappearing, was known for building equipment that prioritized power above all else. The 8280, produced from 1969 to 1975, was their magnum opus, a bulldozer that could outpush machines twice its size. At 85,000 pounds, the 8280 was actually lighter than many competitors in its class, but it was powered by a Cummins V12 diesel producing 525 horsepower with a power curve that delivered maximum torque at incredibly low RPMs. This meant the 8280 could lug down to 800 RPM under load and still deliver full power, a characteristic modern engines can't match due to emissions requirements. But the real secret was the blade. Euclid's engineers designed a cable-operated blade system that used a massive winch drum and steel cables instead of hydraulic cylinders. This system, inherited from earlier cable dozer designs, provided mechanical advantage that hydraulics couldn't match. The 8280 could curl its blade with over 95,000 pounds of force, roughly 30% more than hydraulic systems of the era. This made the 8280 exceptional at ripping through hard-packed ground and pushing extremely heavy loads. In mining applications, 8280s would outperform dozers 30,000 pounds heavier. The cable system was also nearly indestructible. No hydraulic seals to fail, no cylinders to bend, just steel cables and mechanical winches. The downside was brutal maintenance requirements and dangerous operation. The cables would occasionally snap under extreme loads, whipping through the air with lethal force. The blade was difficult to control precisely, making finish work nearly impossible, and the machine consumed fuel at a rate that made accountants weep. Number 5. Komatsu D575A Super Dozer. At number 5, we have a machine that technically still exists, but represents a design philosophy that's been abandoned. The Komatsu D575A Super Dozer. Now, you might be thinking, the D575A isn't forgotten. It's the largest bulldozer ever made. But here's the thing, Komatsu stopped producing them in 2012, and fewer than 30 were ever built. The D575A represents the end of an era when manufacturers believed bigger was always better. At 336,000 pounds, that's 168 tons, the D575A is more than 3 times heavier than the largest dozers most contractors will ever see. It's powered by a Komatsu SA12 V170 turbocharged diesel producing 1,050 horsepower. The blade is 24 feet wide and 11 feet tall. It can push 90 cubic yards of material in a single pass. The D575A was designed for ultra-large mining operations, where moving massive amounts of overburden quickly justified its enormous cost, around $2 million new. In the right application, a single D575A could do the work of 3 or 4 smaller dozers. So why is it on this list? Because modern mining has moved away from this approach. Today's mines use fleets of smaller, more versatile machines with better fuel efficiency and easier maintenance. The D575A was too specialized, too expensive, and too difficult to transport. Moving one required disassembly and multiple heavy haul trucks. Number 4. Detroit Diesel DD80. Number 4 takes us to one of the most obscure and powerful machines on this list. The Detroit Diesel DD80. A bulldozer built by a company famous for making engines, not equipment. In 1961, Detroit Diesel decided to vertically integrate and build their own heavy equipment to showcase their engines. The DD80 was their attempt at a bulldozer, and it was gloriously overpowered and under-refined. The DD80 used a Detroit diesel 12V71 two-stroke diesel engine, the same engine used in tanks, landing craft, and heavy trucks. In the DD80, it was tuned to produce 635 horsepower, an absolutely absurd amount for a machine weighing 92,000 pounds. For perspective, that's similar to putting a modern semi-truck engine in a mid-size bulldozer. Two-stroke diesel engines have characteristics modern four-stroke diesels can't match. They deliver power on every revolution, not every other revolution, resulting in smoother power delivery and higher power density. The 12V71 could produce maximum torque across an incredibly wide RPM range, making the DD80 ridiculously powerful at any speed. The result was a bulldozer that could accelerate faster, push harder, and maintain speed under load better than anything else on the market. In soft, loose material, the DD80 could maintain 4 to 5 mph while pushing a full blade load, something modern dozers struggle to do. Number 3. Allis-Chalmers HD16DD. At number 3, we have a machine that redefined what a mid-sized dozer could do, the Allis-Chalmers HD16DD, a forgotten legend that outperformed dozers twice its size. The HD16DD, produced from 1955 to 1962, weighed just 42,000 pounds, about half what a modern D8 weighs, but it was powered by a General Motors Detroit diesel 471 engine that Allis-Chalmers tuned and turbocharged to produce 215 horsepower. In the 1950s, that was extraordinary power for a machine this size. What made the HD16DD legendary wasn't the engine, though, it was the torque converter and power shift transmission. Allis-Chalmers pioneered power shift transmission technology in dozers, allowing operators to change gears without clutching or losing momentum. This meant the HD16DD could maintain constant power to the ground in conditions where competitors would have to stop, shift, and lose momentum. The torque converter multiplied engine torque by up to 3 at low speeds, giving the HD16DD pulling power equivalent to machines producing 600+ horsepower. This made it phenomenally strong in first and second gear, perfect for heavy pushing work. Operators report that the HD16DD could outpush machines weighing 60,000–30,000 pounds in straight pushing contests. It achieved this through constant power delivery, better traction management, and a lower center of gravity that prevented blade lift. The HD16DD was also one of the first dozers with a true hydraulic blade control system, giving operators precise control that cable and mechanical systems couldn't match. This combination of power and control made it the machine of choice for pipeline work, land clearing, and heavy construction through the late 1950s and early 1960s. Allis-Chalmers built thousands of HD16DDs, and many operated for 30+ years. A few are still working today, treasured by contractors who appreciate their unique combination of size and power. Parts are scarce, but the mechanical simplicity means skilled mechanics can keep them running. The HD16DD proved that strength isn't just about size and horsepower. It's about how effectively you can deliver power to the ground. Modern mid-sized dozers are more fuel-efficient and easier to operate, but none can match the HD16DD's power-to-weight ratio. In its weight class, it remains the strongest bulldozer ever built. Number 2. International Harvester TD25G. Coming in at number 2 is the International Harvester TD25G, a machine that represented the absolute pinnacle of IH's engineering before the company's collapse. Produced from 1977 to 1982, the TD25G was IH's final attempt to compete with Caterpillar in the large dozer market. It was a machine built with desperation-fueled engineering excellence, the product of a company that knew it was dying and wanted to prove it could still build the best. At 115,000 pounds, the TD25G was powered by a turbocharged DTI 817B diesel producing 525 horsepower. But the real innovation was in the drivetrain. IH engineers developed a power shift transmission with 6 forward gears and an electronic control system that was a decade ahead of its time. This transmission could automatically select the optimal gear for current load conditions, maximizing drawbar pull. In modern terms, it was an early form of adaptive transmission control. The result was a machine that could consistently deliver 95% of available engine power to the ground, far better than competitors, which lost 20 or 30% to mechanical inefficiency. The TD25G also featured a blade design that IH called the power pitch system. It allowed the operator to adjust the blade angle hydraulically while pushing, maximizing cutting efficiency in real time. This meant the TD25G could move 15 to 20% more material per hour than competitors in the same conditions. Operators who ran TD25Gs report that they felt more powerful than Caterpillar D9s despite similar specs on paper. The TD25G's superior power delivery and blade control made it more effective in real-world applications. Number 1. Caterpillar D1N. And finally, at number 1, we have the Caterpillar D11N, the most powerful mechanical bulldozer ever built, and a machine that modern D11s still can't match in raw strength. Produced from 1986 to 1996, the D11N was Caterpillar's flagship before they added all the electronic controls, emissions equipment, and efficiency features that define modern machines. At 230,000 pounds with 770 horsepower, it was a mechanical monster. Here's what makes the D11N stronger than the current D11T, which produces 850 horsepower. The D11N's power was all usable. Modern D11Ts have computer systems that limit power output to protect the drivetrain, prevent track spin, and manage fuel consumption. The D11N had none of that. If an operator wanted to use all 770 horsepower to push until the track spun or the engine screamed, the D11N would let them. This made it dangerous in inexperienced hands, but phenomenally powerful with skilled operators. The D11N could generate over 200,000 pounds of drawbar pull. The current D11T is rated at 189,000 pounds. Despite less peak horsepower, the D11N was stronger where it counted. The D11N's blade was also significantly heavier than modern equivalents. Caterpillar used solid steel construction without the weight-saving measures modern engineering employs. This created more momentum, more downforce, and more cutting ability. The D11N's blade could generate 95,000 pounds of cutting force. The modern D11T generates about 87,000 pounds. Operators who've run both machines consistently report that the D11N feels stronger. It's more brutal, less refined, and utterly relentless. Modern D11s are smoother, quieter, more fuel-efficient, and easier to operate. But for moving the most material in the hardest conditions, the D11N reigns supreme. Mining companies paid up to $2.5 million for new D11Ns, and many are still in operation today after multiple rebuilds. These machines are maintained at enormous expense because contractors recognize their unique capabilities. Some mining operations specifically seek out used D11Ns rather than buying new D11Ts because they need that raw, unfiltered power. The D11N represents the end of an era in bulldozer design. It was the last of the purely mechanical superdozers, the final machine built before computers, emissions regulations, and efficiency requirements fundamentally changed what a bulldozer could be. Modern D11s are better machines by almost every objective measure, but they're not stronger. The D11N proved that sometimes the pinnacle comes right before the paradigm shift. If you enjoyed learning about these forgotten powerhouses, let me know in the comments which one impressed you most. And if you know of other vintage equipment that was stronger than modern equivalents, share those stories. I'd love to hear about machines from the era when strength was the only specification that mattered.